Okay, so now we're going to use this basic thinking structure to think about the question of the hot hand. Now, if a basketball player has abnormally long runs of consecutive baskets in their play, you might say, or the observer might say, that this player has the hot hand. So the first thing we want to think about is, how long is an abnormally long run of baskets? Or, if a player has a 50% chance of making a shot on every attempt and takes 100 consecutive shots, how long should the longest run of consecutive baskets be in the data if their chance of making a shot remains at 50% on every attempt? So we're going to build a little model for a player with a 50% chance of making a shot on every particular shot, every shot they take. Before we think about a player who takes 100 shots or some specific number of shots, we're going to use our basic probability to think through an intermediate experiment, experiment A. So we're going to use what we've discussed already about setting up a sample space, flipping a coin k times, and that simple framework to try to get a handle on how long the longest run of baskets should be if we run this experiment, experiment A, many times. This is it. This is experiment A. A basketball player with a 50% chance of making a basket on every shot is going to keep taking shots until they miss a basket. So what is the sample space for this experiment? What can happen? So the player is going to shoot. If they get a basket, then they shoot again. If they miss, then they stop. Well, let's think about it. Let's think about what might happen. On the first shot, they might miss, or they might get a basket. Okay, so the sample space for this experiment is the following. For the first shot, I might miss, and that's it. One trial of the experiment is over. When I miss, I stop. On the other hand, I might get a basket on the first shot, and then perhaps miss on the second, and then I'm done. That trial of the experiment is over. On the other hand, I might first get a basket, then get a basket on the second shot, and then miss, and then I'm done. Then that trial is over. And this can go on. I might get 3 baskets and then miss, or I might get 4 baskets and miss, and you get the idea. And the new thing about this sample space is this could go on forever. So we use these 3 little dots to indicate etc., etc., etc. The nth outcome, the general outcome, is a string of baskets of length m, or n, followed by a miss. But we don't stop for any particular n. It is conceivable that this sample space, this string of baskets, could go on forever with no miss. It's highly unlikely, but it is conceivable. So this is an infinite sample space, and this is what it looks like. And how are we going to use this to get an idea of the probability of a basket of a particular length showing up in the string of baskets from this basketball player?